Good morning, friends. Today we are going to discuss about the MCQ question 4, unit test and internal test taken in January month. Right? Okay, in chapter 11, some MCQ question I give the hint how we solve it for your practice, because the most of the student says that sir we have some difficulties in MCQ question. For that purpose, here this type of the practice is done by us. Okay, now the first question is the de Broglie wavelength of an electron in nth Bohr orbit is. What is the de Broglie wavelength of electron in nth orbit? For that purpose, we know that now if the angular momentum of an electron in nth orbit is from the Bohr's hypothesis, so mvr is equal to nh upon 2 pi. We require the de Broglie wavelength, therefore angular momentum in nth orbit is mvr is equal to nh upon 2 pi. Now the de Broglie wavelength lambda is equal to h upon p. We are interested to first obtain the momentum of an electron. Therefore, mv is equal to nh upon 2 pi r is the momentum, is equal to p. Now de Broglie wavelength, in other words, from this h upon p, therefore h upon p is equal to what we obtain? The 2 pi r upon n. 2 pi r upon n, there is the de Broglie wavelength, lambda. Therefore, de Broglie wavelength of an electron in nth orbit is lambda is equal to 2 pi r upon n, that much angstrom. Now we know that from the Bohr's hypothesis, what is the angular momentum in nth orbit? So mvr is equal to nh upon 2 pi. Now the mv is the momentum, therefore mv is equal to nh upon 2 pi r. Now the de Broglie wavelength is equal to lambda is equal to h upon p. Now in h upon 2 pi r is equal to momentum, therefore h upon p is equal to Bohr's the de Broglie wavelength. Therefore h upon p is equal to 2 pi r upon n. That is the de Broglie wavelength of an electron in nth orbit. That is the 2 pi r upon n angstrom. Now after that, if the de Broglie wavelength of an electron at 927 degrees centigrade is lambda, then its de Broglie wavelength at 27 degrees centigrade is. Now here the temperature T1 is given 927 degrees centigrade. At this temperature, de Broglie wavelength lambda 1 is equal to lambda. Now at new temperature 27 degrees centigrade, what is the de Broglie wavelength lambda 2? Now de Broglie wavelength lambda is equal to h upon p. Lambda is equal to h upon p. Now what is the relation of the momentum with respect to the absolute temperature? So from the average kinetic energy, half mv square is equal to 3 by 2 kBt. 2 to cancel. By using this concept, P is equal to under root of 3n kBt. Therefore, H upon under root of 3n kBt. So that is the de Broglie wavelength. M is the mass is constant, Kb is constant, right? Therefore, lambda proportional to the 1 upon under root of T. Lambda proportional to the 1 upon under root of T. So using this concept, therefore lambda 2 upon lambda 1 is equal to under root of T1 upon T2. T1 upon T2. T1 is given the 927 degrees centigrade, here 27 degrees centigrade. We have to convert into the Kelvin. Therefore, 927 plus 273 Kelvin upon 27 plus 273. Therefore, lambda 2 upon lambda 1. That is the 1200 square root upon 300. So is equal to 2. Therefore, lambda 2 is equal to 2, lambda 1 is equal to 2 lambda. As the temperature decreases, de Broglie wavelength increases. That means at 927 degrees centigrade, what is the de Broglie wavelength? The double de Broglie wavelength we obtain at 27 degrees centigrade. Clear it? Okay. Now keep in mind this equation. The de Broglie wavelength relate with the inversely proportional to the square root of absolute temperature, and also inversely proportional to the mass of a particle. Therefore, lambda is equal to h upon 3 under root of 3 mkBT. Now, why the P is equal to this? So we know that the half m this way is equal to 3 by 2 kb into T. 2 cancel, right? So how do we obtain the equation of the velocity? The momentum. Therefore, the momentum P is equal to, we multiply both sides by m. Therefore, m square v square is equal to 3 kb m into T. So that is the square of the momentum, 3 m kbt. Therefore, momentum P is equal to under root of 3m kbt. Already we derived this equation when we discussed about the MCQ question for the JEE, NEET and also asked in Gate. So again we repeat it, why the momentum is equal to under root of 3m kbt. According to this equation, every kinetic energy is equal to 3 by 2 kb into T. So here I subuse the P is equal to directly under root of 3m kbt. So 3m and kb are constant. Kb is the Boltzmann constant, m is the mass of the particle, 3 is constant. Therefore, de Broglie wavelength inversely proportional to the square root of absolute temperature. So here the two different value of the temperature given. We have to find out the lambda 2 at T2 temperature. Therefore, lambda 2 upon lambda 1 is equal to under root of T1 upon T. So by using this concept, we can find out the lambda 2 is equal to lambda. Now listen here, the temperature are given in degrees centigrade. So here the ratio of the temperature, degrees centigrade not cancel. But it is necessary we have to convert into the Kelvin. So most of the students make the mistake here, 927 divided by 27, because there is the ratio, therefore degrees centigrade cancel. But here the temperature is in Kelvin is required, not degrees centigrade. Okay, now next is third. If the nucleus of the proton, electron and uranium have the same wavelength, then which have the maximum energy? So which of the electron, proton or the uranium has the maximum energy? For that purpose, the E is equal to half mv square. That means the energy is equal to half mv square. Therefore, 2E is equal to mv square. Therefore, 2me is equal to m square v square, actually our momentum, square of the momentum. Therefore, P is equal to under root of 2me. Again, E is equal to half mv square, that is the energy. Therefore, take the 2 here, 2E is equal to mv square. Here we require the wavelength are given. Therefore, wavelength is equal to h upon p. So, we require the value of or the equation of momentum in terms of E. Therefore, 2E is equal to mv square. Multiply both sides by m. So, 2me is equal to m square square. That means the momentum square. Therefore, momentum P is equal to under root of 2m. Now, wavelength. Lambda is equal to h upon p. Lambda is equal to h upon p. Therefore, h upon under root of 2 in 2me. Making the square. Therefore, lambda square is equal to h square upon 2me. 2m. Right? Okay. Therefore, E energy is equal to h square upon 2m lambda square. But lambda are same. Therefore, E proportional to the 1 upon m. E proportional to the 1 upon m. Photon has less mass. So its energy is maximum. So its energy is maximum. Now listen. Here the wavelength of the photon, electron and uranium are given same. So which of them has the maximum energy? So energy is equal to half mv square. Therefore 2E is equal to mv square. Multiply both sides by m. Therefore, 2me is equal to m square is equal to momentum square because the P is equal to mv. Therefore, P is equal to under root of 2me. Now, de Broglie wavelength lambda is equal to h upon p. Substitute P. Therefore, h upon under root of 2me. We require the relation between the energy and wavelength. Therefore, making the square, lambda square is equal to h square upon 2me. Therefore, E is equal to h square upon 2m lambda square. But here, lambda are same for given three particles, photon, electron and uranium. Therefore, energy is inversely proportional to the mass. Now, the photon has the less mass compared to the electron and uranium. Therefore, the photon has the maximum energy. Photon has maximum energy. Now, next is, what is the wavelength of photon in A having the energy is E? Again, what is the wavelength of photon in A medium having the energy is E? Therefore, the wavelength in A is lambda is equal to C upon F. Or we know that C is equal to F lambda. Therefore, wavelength in A lambda is equal to C upon F. Lambda is equal to C upon F. Multiplying both sides by H. Right? Or the right hand side by H upon H. Therefore, lambda is equal to HC upon HF. HF is the energy. HF is the energy. Therefore, HC upon E. H is the Planck's constant, C is the velocity of light in vacuum, and E is the energy. Here the photon has the energy is E. Therefore, its de Broglie wavelength lambda is equal to Hc upon E. Again, here the photon is given. What should be its de Broglie wavelength in a medium? Its energy is given, that is the E. Now we know that the velocity of light C is equal to F into lambda. Therefore, wavelength in A medium lambda is equal to C upon F. Right? Okay. Now, S we multiply and divided by H of this equation, right hand side of this equation. Therefore, lambda is equal to Hc upon Hf. Hf is the energy of one photon. Therefore, lambda is equal to Hc upon Hf. Hf is equal to E. Here the photon has the energy Z, therefore its de Broglie wavelength lambda is equal to hc upon P. 8. Okay. Now after that, the source having the power is 4 kilowatt emits the photon at rate of 10⁻20 per second. The emitted radiation lies in which region of electromagnetic spectrum? Here the one source having the power is 4 kilowatt. Therefore power P is given the 4 kW. That means the 4 into 10 is to 3 watt. Emits the photon per second. Therefore N is given 10:20. N is given the 10:20. So we have to find out the emitted radiation lies in this region. That means we have to find out the wavelength. If we find out the wavelength, so we can judge about that. That is the wavelength lies in which region, or this wavelength belongs to which region of electromagnetic spectrum. Now we know that the power P is equal to N. Power P is equal to N. E is equal to HF. That means the NHF. Now, but we know that C is equal to F lambda. Therefore, F is equal to C upon lambda. Therefore, power P is equal to NHC upon lambda. NHC upon lambda. Therefore, lambda is equal to NHC upon power. Substitute the value. N is given 10:20. H, Planck's constant 6.625 into 10⁻34. C, velocity of light 3 into 10⁸. Upon power 4 into 10⁻3. 4 into 10⁻3. Thus we obtain the value of lambda is 4.927972 into 10⁻⁻9 meter. So it's 49.7 into 10⁻⁻10 meter is equal to 49.7 angstrom, which is in X-ray region. Which is in X-ray region. So that is the wavelength. Here the power of the source is given. That emits the number of the photon with the 10⁻20 per second. So the emitted radiation is of or belongs to which region of the electromagnetic spectrum. For that purpose, we require the equation of the wavelength, because first we have to find out the wavelength of the radiation. After finding the wavelength of radiation, we can judge about that this radiation belongs to which region of electromagnetic spectrum. Now, total power is equal to numbers of photon into energy of one photon. That means the NE or the NHF. F is the frequency of the incident photon. But here the frequency not given, we are interested to find out the wavelength. Therefore, C is equal to F lambda. Therefore, F is equal to C upon lambda. Therefore, power P is equal to NHC upon lambda. So, from this equation, lambda is equal to NHC upon P. Now, substitute all value. Power P is equal to 4 kilowatt. 4 into 10⁻3. N is equal to 10⁻20. H, Planck's constant. C is the velocity of light in vacuum. So let us substitute and find out the wavelength lambda. So that is the 49.7 angstrom. That is the short wavelength is in region of X-ray. So this radiation belongs to the X-ray region of electromagnetic spectrum. Now, after that, the next. What is given? One photon and one electron have the same energy. Then, the ratio of the wavelength lambda photon to the lambda electron. Right? Now we know that the wavelength of photon having the energy are same. Right? So lambda P is equal to hc upon E. And wavelength of electron lambda E is equal to h upon under root of 2me. H upon under root of 2me. Now wavelength of photon and electron are known. We have to find out the ratio of lambda photon to the lambda of electron. Right? Lambda of photon, this hc upon E, and that is this. Therefore, that is the hc upon this. hc is cancelled. Therefore, under root of 2me, under root of 2me upon only E. Only E. Right? Okay. Wavelength of an electron is h upon under root of 2me. Okay. Now the ratio of the wavelength of photon to the wavelength of electron is. So here we write in that form first. Lambda P. Lambda P is this hc upon E. And that is the inversely multiply 2me upon h. H is cancelled. Right? Therefore, we obtain like this way C into under root of 2m upon under root of E. Because the E is equal to under root of E into under root of E, 1 times under root of E is cancelled. Therefore, C into under root of 2m upon. Here the energy are same energy. Then the ratio of the lambda of photon to the lambda of electron. So it's equal to C into under root of 2m upon E. Therefore, lambda upon P upon lambda E, lambda P upon lambda E proportional to the 1 upon under root of E. Proportional to the 1 upon under root of E. So that is our answer, 1 upon under root of E. So here it is necessary to know that what is the equation of the wavelength of photon and what is the equation of wavelength of electron. Wavelength of photon is hc upon E, having the energy is E, and wavelength of the electron having the energy is E is He is equal to h upon under root of 2me. Taking this ratio, we obtain the C under root of 2me. C and m are the constant. Therefore, this ratio is depends on 1 upon under root of E. So friends, this way we can solve the most of the MCQ question if a concept about the theory is clear. Without reading or without the preparation of the theory of this chapter, we are not able to solve the MCQ question. Here keep in mind the concept of the theoretical part of the theory of this chapter. So we are using the equation already we learned in theory portion. We are using the equation, we can solve the numerical or the MCQ type question. Clear it? Okay.